Alrighty guys, so this is a video that is going to complete lesson 6, successive differences in polynomials. Last week we had stopped in the middle of example 4 with this table. I've drawn the table here. You should have it in your notes. We saw that we have a constant term 6 in our third differences column, and so we said that we have a cubic relationship here. If we would have had a constant term in the second differences column, remember it would have been quadratic. If it would have been in the first differences column, it would have been linear. But since it is in the third differences column, it is cubic because a degree 3 polynomial is a cubic. So the relationship that this polynomial is going to have is going to be y equals ax cubed plus bx squared plus cx plus d. So our goal here is we want to find A, B, C, and D to fill in those numbers, and then we'll have the polynomial that satisfies all of these ordered pairs. And by ordered pairs, I mean that, remember I said 0, 2, 1, 1, they're all points on this graph. They just organize them in a table for us. So 2, 6, and so on down the line. So we're going to be using all of those points eventually. So just keep those in mind too. You don't have to write these out, but just so you know, these are ordered pairs. Remember the x column and the y column. So last week I talked about how whenever we have in the third differences column, we set our constant number equal to 6a. And in this case, our constant number is 6. So if your constant number, if that third differences number had been 17, you would have set 6a equal to 17. But in this case, it's 6, so that's why we're setting 6a equal to 6. Remember, if it would have been in our second differences column, which you might see on your problem set, hint, hint, you set 2a equal to whatever constant is in this column. So if it's 2 or 4 or 6 or whatever, you set 2a equal to whatever that number is. If it's in the first differences column, you set a whatever equal to that number is. So I don't think you'll see it with the first differences column in your problem set, but I did want to mention with the second differences problem set because I do think you'll see that. So going back to this, our first step is going to be solving for a. So we just need to isolate the a. So we're going to divide by 6 both sides. And we get a equals 1. So after each step, I like to rewrite my equation with every coefficient that I know. So now that I know that a equals 1, I have y equals 1x cubed plus bx squared plus cx plus d. So that's my new equation so far. I also like to box a equals 1 just so I have it at the end. All right, so my first step is done. I'm going to change colors for my second step. So for my second step, I'm going to go into my point values because I'm going to use one of them. Now, you might just think, okay, we're going to use the top one. I want you to use whichever one that x is equal to 0 because that's going to be the easiest one. So in this case, it is the top one. So since x is equal to 0 in this one, I'm using 0, 2. And I'm going to plug that in. And I'm going to plug it in right here to my new equation. Since the y value is equal to 2, I'm going to say 2 equals 1 times 0 cubed plus b times 0 squared plus c times 0 plus d. Now, look carefully at what happens. 1 times 0 is 0. Whatever b is, if we multiply it by 0, it's 0. Same with c. Whatever c is, if we multiply it by 0, it's 0. So we end up getting 2 equals d. So now we've solved for our second unknown, and it's d. So we're not going in order, and that's okay. All we need to do is solve for all of them. We don't need to necessarily do A, then B, then C, then D. It's fine that we did A and then jump to D. So far we have y equals, we know 1 for A, x cubed. We don't know B yet, so we're going to leave it bx squared. We don't know C yet, so we're going to leave it cx. But we do know D, so we're going to do plus 2. So now we're halfway there. All we need to know are B and C now. So I'm going to switch colors again for my third step. And I'm going to go into another point in my table. And this time it doesn't matter which point you use. You could use 5, 117, but arithmetic-wise, that would be a lot harder to work with than 1, 1, and 2, 6. So we're going to work with 1, 1 first. So first we're going to plug in 1, 1 to this equation. So y is 1, and x is 1. So 1 times 1 cubed plus b times 1 squared plus c times 1 plus 2. So this gives me 1 equals, this is 1 plus 2, which is 3. So I have 3 plus b plus c. So I'm going to subtract the 3 from both sides. And I get negative 2 equals b plus c. Now, that's about all I can do with that equation. Since I have 2 variables in that equation, I need 2 equations to solve for 2 variables. So I'm going to make another one just like it using 2, 6. So I'm going to do the same thing with 2, 6. I'm going to plug it into this right here. I'm going to make another linear equation, and then we're going to solve them simultaneously. So 6 is your y value, so I have 6 equals 1 times 2 cubed plus b times 2 squared plus c times 2 plus d, which is 2. So I have 6 equals, this is 8 plus 2, which is 10. So 10 plus 4b plus 2c. When I subtract 10 from both sides, I get negative 4 equals 4b plus 2c. I'm going to go ahead and divide everything by a 2. Just because it's going to make my life a little bit easier. So I have negative 2 equals 2b plus c. I'm going to change colors again. So now we're on to probably the, I wouldn't say the hardest step, but probably the one that's going to give you guys the most struggle. Because we need to solve this equation and this equation simultaneously. So for step number 5, we've got negative 2 equals b plus c, and negative 2 equals 2b plus c. And what we're going to do is combine them and eliminate one of the variables to solve for the other. So I notice that if I run a negative through the top variable, I get 2 equals negative b minus c. So all I did was rewrite this as this right here. Now I'm just going to add straight down. So negative 2 plus 2 is 0 equals, my equal sign just comes straight down. 2b minus b is just b. And then c minus c, that's what I want to happen. I want one of my variables to cancel out or sum to 0. So now I have that 0 is equal to b. So now I have A, I have D, and I have B. All I need is C. So to find C, what I have to do, I'm running out of colors here. To find C, what I have to do is plug that into, I know that B plus C is equal to negative 2. So 0 is B plus C equals negative 2. That means that C is equal to negative 2. So finally, I'm ready to rewrite with all of my coefficients. So I've got y equals 1x cubed plus 0x squared plus negative 2x plus 2. And you might say, well, that's a really, really ugly way of writing an equation. And I would say you're right. I would put a frowny face by this, even though it's technically correct. I would hate to see this because, first of all, we never put a 1 coefficient. It's understood. We don't need to put this 0. Plus a negative 2x is just a minus 2x. So we're going to write this much more nicely. So we have y equals x cubed. This doesn't need to be said. Plus negative 2x is minus 2x plus 2. So this right here is the cubic equation that satisfies the set of points that were in the table. Oops. That were in the table. Okay? So the last thing that it says in your notes is that it says to give evidence that your equation is correct. So all we have to do for that is plug in a couple points. So we're going to plug in this one and this one. If we get true statements, then that's evidence. So if we plug in, so to check, if we plug in 323 to our final equation, we will get 23 equals 3 cubed minus 2 times 3 plus 2. So let's see, does 23 equal 3 cubed is 27 minus 6 plus 2? Well, 27 minus 6 would be 21 plus 2 is 23, so that definitely works out. If we check 458, we would get 58 because that's the y value equals 4 cubed minus 2 times 4 plus 2. So we're checking if 58 is equal to, let's see, 4 cubed would give me 64 minus 8 plus 2. 64 minus 8 is 56 plus 2 is 58. So that also checks out. And feel free to check 117, but I think that 2 problems or 2 points is sufficient evidence. So this right here that I'm circling in yellow is our equation that satisfies that table. So this is really, really, really similar to your problem set numbers 4 and 5. So you'll have to do this on 4 and 5. Now I believe that number 4 is just a quadratic, so it's much, much shorter. Okay. 5 is another cubic, so it's going to be a little bit longer like this one. But remember, you can refer back to this video and just follow these steps when you do problem set number 5. So before I end the video, I just want to jump to your problem set and I want to jump to your problem set and just help you set up the tables for 1, 2, and 3 because they don't set them up for you. So number 1, it says create a table to find the second differences for the polynomial 36 minus 16t squared for integer values of t from 0 to 5. So they're using t and not x, so don't freak out. So t, and then we're doing 36 minus 16t squared. So integer values from 0 to 5. Remember, integers are just 0, 1, 2, 3, 4. They're just whole numbers. So from 0 to 5 is just what I just said. So 0, 1, 2, 3, 4, and 5. So those are the numbers that you'll plug in to t. And then obviously you'll do what the problem says. This specific one says find the second differences. So you'll need 2 more columns to do the first and the second differences. For number 2, it's really similar. Except they use s. And they use s squared minus s cubed minus s squared plus s, and they're asking for third differences, so you'll have to go all the way out to first, second, third differences for that one. And they want integer values from -3 to 3, so you'll go -3, -2, -1, 0, 1, 2, and 3. And then remember, when you're plugging these in, you plug -3 in right here, and right here. Now be careful because -3 cubed is equal to -3 times -3 times -3, which will be a -27. So a negative number cubed is equal to a negative number. I just want to remind you of that. And then finally, for number 3, we set it up the same. It's just that, like the examples in our problem set, and they want second differences for number 3. You're not using numbers, you're actually using stuff with variables. So they want you to use n plus 1, n plus 2, n plus 3, and n plus 4. So that's what you're plugging into x squared. So for example, when I plug in n to x squared, I get just n squared. When I plug n plus 1 into x squared, I get n plus 1 squared. So you need to work that out. and you actually get n squared plus 2n plus 1. For n plus 2 squared, you get n squared plus 4n plus 4. Okay? For n plus 3 squared, you get n squared plus 6n plus 9. So you guys figure out n plus 4 squared. Then you'll have to do the first and second differences. Remember to run the negative through. You cannot forget that. Okay? So that's just a couple hints on your problem set. Like I said, number 4 and 5 are like example 4 from your notes. Number 6 is also like example 4, but part B is a little different. So I want to see what you guys can come up with for that. If you need to do part C before part D, that's fine. But I really like to see how you guys figure out part B. So do not do 7, and I'll put this on Google Classroom too. You don't have to do number 7 on the problem set. Just do 1 through 6 as your homework after watching this video. So hopefully this video helps and you're able to reference it while you're doing your homework too. But I'll see you guys soon, and great job today.